Assalamualikum OyaRahmatullahe OyaBarakatuhu. Welcome to my virtual classroom, MKA Classroom. Now let's start today's video tutorial.
Today we will start rates of return or yields. The valuation of any long-term financial instrument involves a capitalization of that security's income stream by a discount rate that we call required rate of return, appropriate for that securities risk. If we replace intrinsic value in our valuation equation with the market price of the security, we can then solve for the market required rate of return. This rate, which sets the discounted value of the expected cash inflows equal to the security's current market price, is also referred to as the securities market yield. That's why in this session we will try to discuss the yields of our securities. Firstly, we will try to see yield to maturity. Yield to maturity, the expected rate of return on a bond if bought at its current market price and held to maturity. That is the yield to maturity. That means rate of return to maturity. The expected rate of return on a bond if bought at its current market price and held to maturity. The market required rate of return on a bond, KD, is more commonly referred to as the bond's yield to maturity. Yield to maturity is the expected rate of return on a bond if bought at its current market price and held to maturity, is also known as bond's internal rate of return or IRR. Mathematically, it is the discount rate. Mathematically, it is the discount rate that equates the present value of all expected interest payments and the payment of principal or face value at the maturity with the bond's current market price. We can again say that this is the discount rate that equates the present value of all expected interest payments and the payment of principal or face value at maturity with the bond's current market price. That's we can call the yield to maturity. So here we will see the formula of YTM, yield to maturity, equal to I means annual interest of the bond or annual coupon payment of the bond plus MV, maturity value of the bond, minus C. C means current price of the bond, divided by N. N means number of period to maturity, or number of year to maturity of the bond. Then divided by MV, maturity value of the bond, plus C, cost of the bond or current market price of the bond, divided by 2. This is actually the interpolations formula to find out the value of YTM. That means if you purchase this bond and hold it for till maturity, then what type of interest you have actually earned, that can be find by this formula, interpolations formula. So again we will see, actually this formula is yearly formula. Yearly, whenever interest is paying by yearly or coupon paid by yearly, then we are using this formula. YTM equal to I means coupon payment, yearly coupon payment, plus MV minus C divided by N, divided by MV plus C divided by 2. So what's the value we are seeing, that I, amount of annual interest, MV, maturity value at the end of holding period, C, cost or current market price of the bond, N, holding period till maturity. So remember that sometimes some bond will provide us semi-annual interest or semi-annual coupon. That means it provides semi-annual coupon, yearly two times it provide interest, 2 times in a year. So that should be called the semi-annual interest or a semi-annual coupon. Semi-annual. So here we will use semi-annual formula. Semi-annual. So sometimes some bond provide semi-annual interest. So this formula we will easily convert to the semi-annual YTM. So if YTM should, sometimes we have to calculate it is a semi-annual. So there should be I divided by 2 and N into 2. There should be. So here we will see I means annual interest. I means annual interest divided by 2 and N into 2. Nothing should be changed. I divided by 2, where you can simply write down the semi-annual payment, the value, and N should be divided into 2. So here has an example that we will going to do, that has the 12 years to maturity and 80 taka annual coupon. So 80 taka annual coupon and 12 years to maturity. So that is we will going to do that problem. So that we are talking about this matter. So here 80 taka divided by 2 and 12 years into 2. So our coupon payment should be the 40 taka, and our here's the ends value should be 24. If the annual payment, if the bond is semi-annually bond, then here we will easily calculate our value. So at first we are try to learn the yearly, that is bond is yearly bond, that is paying yearly interest. But sometimes the bonds will provide you semi-annual interest, then we will use this type of matter. So I divided by 2, or you can put down the 40 taka, and n into 2, or you can write down 24 periods, or 24 12 years into 2 equal to 24 periods. So in this way we can easily calculate the YTM into maturity. Here we have said that is the interpolation formula. So interpolate, what is it? Estimate an unknown number that lies somewhere between the two known numbers. We use this interpolations formula for finding our YTM. So here has an examples that you can use this formula to find out this value. Consider a 1000 par value bond. 1000 par value bond, that means MV, maturity value 1000 from our formula, with the following characteristics. The current market price is 761, that means C 761. 12 years to maturity, that means N equal to 12. 8% coupon rate, that means 8% coupon rate. Interest paid annually, this bond interest paid annually, that means 8%, 1000 into 8%, that means I. If you see 1000 into 8% should be 80 taka. Our interest is 80 taka. Now if we put this value to our YTM formula, then we can find out our L2 maturity. That means what is the interest to hold this bond till maturity. Now we are going to put this value to our interpolation formula. If we put this value to our interpolation formula, then we will see our coupon payment 80 taka per year plus MV, maturity value 1000, minus current market price 761 divided by 12, divided by 1000 plus 761 divided by 2. By solving this problem to our calculator, we will see our approximate our L2 maturity is 11.35%. That means if we purchase this bond with 761 taka from the market and hold it for maturity, then we will receive 1000 as our maturity and we will earn 11.35% for our return for holding this security. Remember that this YTM actually approximation of exact percentage. Keep in mind that interpolations gives only an approximation of exact percentage, not actually exact result is this. It is actually approximation our percentage. It is important to keep in mind that interpolation gives only an approximation of exact percentage. So here yield to maturity has 11.82%. We have 11.35 percentage and 12.12 percentage in this tabular method format. They did tabular method format. The result is 12.12%, and computer shows result 11.82%, and we have our calculator shows 11.35%. So don't worry, here it is said that it is important to keep in mind that interpolations give only an approximations of exact percentage. Now we will see behavior of bond prices. So it may have the bond discount or bond premium. Bond discount, the amount by which the face value of bond exceeds its current market price. Then the bond discount. Bond premium, the amount by which the current market price of bonds exceeds its face value. So these are the bond discount and bond prices. So here you will see when the market required rate of return is more than the stated coupon rate, the price of the bond will less its face value. Such bond is said to be selling at a discount from its face value. The amount by which the face value exceeds the current market price is called the bond discount, or you can call this type of bond the discounted bond. When the market required rate of return is less than the stated coupon rate, the price of the bond will be more its face value. Such bond is said to be selling at premium over the face value. This amount by which the current market price exceeds the face value is the bond premium, or you can call this type of bond is the premium bond. When the market required rate of return equals to the stated coupon rate, the price of the bond will equal to its face value. Such bond is said to selling at par. If the interest rate rises so that the market required rate of return increases, the bond's price will fall. If the interest rates fall, the bond's price will increase. In short, interest rates and bond prices move in opposite directions, just like two ends of child saw. Here has YTM and semi-annual compounding. So it is already we have discussed previously, that is interest per coupon payment divided by 2 and n should be multiplied by 2 to find out the YTM who provides its interest semi-annually. Then we will see yield to preferred stock. Only here we will substituting current market price P0 or P0 for intrinsic value V in the preferred stock valuation model. So then the formula for yield of preferred stock, KP, required rate of return on preferred stock, equal to DP divided by P0. DP means the still stated the annual dividend per share of preferred stock, dividend per share of the preferred stock, and P0 equal to the value of a preferred stock or intrinsic value of preferred stock or market price of preferred stock. Then here as an example, they assume that the current market price per share of ZARF companies is 10%, 100 per value preferred stock is 91.25. that is current market price is 91.25. so here our formula said that we will use current market price instead of intrinsic value. So here we will see preferred stock is 91.25 its current market price, that means P0, and 10% its dividend, that is taka 10. Then if we divided this, they are our required yield is 10.96%. After that we will see yield 1 common stock. After that we will try to see yield 1 common stock or rate of interest on common stock. So formula is simply KE, required rate of return 1 common stock, equal to expected dividend 1 divided by P0 plus G. So here as I said that rate of return that sets a discounted value of expected cash dividend from a share of common stock equal to the share's current market price is yield 1 that common stock. For example, the constant dividend growth model was appropriate to apply the common stock of a particular company. The current market price P0 could be said in this way, P0 equal to dividend expected dividend 1 divided by record rate of return minus G. That is the formula for our common stock valuation model. So that formula is actually solved for required rate of return. So if we use that formula, we can find the value of KE or required rate of return. KE, who is in this case the market determined yield 1 a company's common stock, that we can get this equation. So this formula for our finding yield 1 common stock, KE expected KE equal to dividend 1 divided by P0 plus G. That is the formula for yield 1 common stock. So here as an example of our finding the yield of common stock, here is the example. What market yield is implied by a share of common stock currently selling for 40 taka, whose dividends are expected to grow at a rate of 9% per share, and whose dividend the next year is expected to be 2.40. So our formula shows that expected dividend divided by current market price of the share, that means P what current market price, D1 expected dividend, our expected dividend 2.40 divided by our current market price of this share is 40 taka. 2.40 divided by 40 and plus G, it will expected to grow at a 9% per year, so that is plus 9%, that means 0.09. so this is our required yield of this common stock, that is 15%. So our yield, market yield is 15%.
This all about today. Stay home, stay safe. Assalamualaikum warahmatullahi wabarakatuhu.